All right, so now we understand that basically an absolute value graph looks like a V-shaped graph. But what do we do if we have a more involved absolute value function? How do we graph those? Well, there's typically two different ways that are taught how you can graph absolute value graphs. I'm going to show you both of them. We'll call this video part 1. I'll show you the other way in the next video. We'll call that part 2. So one way is as follows. What you can do is first of all find the x coordinate of the vertex, which I'll show you how to do in just a minute. And once you find that, then you're basically just going to make a little mini XY table around that vertex. Because if you can figure out what it looks like to the left and the right of the vertex, you'll know if the absolute value graph, the V, goes up or down and how wide or how steep it is, things like that. Connect the dots and you're done. All right, now the logical question here in these 3 steps is, how exactly do you find the x coordinate of the vertex? Well, here's how you do that. You set the inside of whatever is inside the absolute values equal to 0 and you solve it. So whatever would make the inside of the absolute values be 0, that x coordinate, that x value, will be the x coordinate of your vertex as well. All right, so let's try this with an example. So I've got one made up here. So let's say our function is the absolute value of not just x, but 2x minus 6 quantity plus 1. So there's a lot of different stuff going on here, and I'd like to graph him. All right, so the first thing we're going to do is we're going to take the inside right here, the 2x minus 6. We'll set that equal to 0 and we'll solve it. Obviously that's at x equals 3. So at 1, 2, 3, this is going to be where the vertex is. Now I don't know what the y value is yet, but it's going to look something to the effect of either like this or possibly like this. We're not really sure all the details yet, but I do know that the vertex will be at 3. All right, so how do we get the details? Well, we're going to make a mini XY table around 3. So maybe I'll do 3, 2, 1, and 3, 4, 5, 6, or something like that. All right, I'll do the arithmetic pretty quickly. You can check my algebra on this. I think when you plug in 1, I think final answer you'll get a 5. If you plug in a 2, I think you'll get a 3. If you plug in a 3, 3 times 2 is 6, 6 minus 6 is 0. Absolute value of 0 plus 1 is 1. Plug in a 4, 2 times 4 is 8, minus 6 is 2. 2 and 1 make 3. And then plug in a 5, I think you'll get a let's see, 10 minus 6 is 4, 4 and 1 make 5. And I tell you what, I don't even think I need the 6. I'll just stick with a even smaller table here. So I've got 5 values, 2 before 3 and 2 after 3. And these are all the x, y ordered pairs that are on this guy's graph. So we've got 1, comma, 1, 2, 3, 4, 5, 2, comma, 3, 3, comma, 1. Then I've got 4, comma, 3, and 5, comma, 5. If you take a look, that looks pretty good. It's a V-shaped graph, and if you notice, it looks like this guy has a vertex really at 3. It looks like it turns around at 3. So that's why this works out so well. Finding the vertex just basically shows you where your graph is centered, the absolute value graph. And then by picking a few points before and after, you see if the absolute value V is going up or down and that sort of thing. This one you'll notice is actually, to me, it looks like it's actually even a little a little more narrow than your standard absolute value. And truth be told, the reason that happens is actually because of this 2 right here, which we won't really get into a lot of those details. But anyways, so this is one way that you can graph absolute value functions, and in the next video we'll show you the other way you can graph them as well.